Hey everyone, for the day 4 worksheet, which is the quadratic functions worksheet number 3, we are talking about zeros, roots, and intercepts. So let's go through those terms so we know what we're talking about. For any graph, and we've done this with lines already, but for any graph, the point where your graph crosses the y-axis is called the y-intercept. The coordinates of this point are going to be 0, comma, something. So 0, comma, something. The x-intercepts are the points where your graph crosses the x-axis. So this is the x-axis, you all know that. So these points are going to be something, comma, 0, and something, comma, 0. So if I were to kind of guess, this looks like it might be 0, comma, -2. So that would be a -2. This one looks like 1, comma, 0. So that would be a 1. This one looks like maybe -4, comma, 0. So this would be a -4. So the number that goes in these blanks is what we're going to work on finding. Now, the x-intercepts are also called zeros or roots. They're called zeros because it's where the function values, which are the y's, are 0. That's why they're called zeros. So it doesn't matter whether you want to call them zeros or roots or x-intercepts, we find them all the same way. So to find y-intercepts, we let x be 0. To find x-intercepts, we let y be 0. Now, we have already done this with lines in the past. So this concept is not new, but now we're applying it to a quadratic instead. So let's take a look at a couple examples. So on your worksheet, you are going to be asked to find y-intercepts and to find zeros. And we're going to do it algebraically and not by graphing them. So remember, and I'm going to write this down, to find y-intercepts, we let x equal 0. And to find zeros, which are x-intercepts, we let y equal 0. So let's work out a couple of these. So if I let x be 0, I get 0 squared minus 7. That's 0 minus 7, which is -7. The actual point then would be the point 0, comma, -7. For this one, notice that it's got that f at x notation. That's fine. That's just a fancy way of saying y. So when I put 0 in for x, notice that any term that has a 0 in it is going to turn into 0. So I get 2 times 0 minus 7 times 0, which is 9. And so for these, if it's written in this format, where you've just got the x term and then maybe the x term, whatever, what's going to happen is terms with x's in them are going to disappear. So you're really just looking at this number here. So if your equation looks like y equals ax squared plus bx plus c, this c number is the y-intercept. So those are pretty easy to find. Now, for this one, you have to actually put the number in and do the calculation. So let's do that. So remember, we're letting x be 0. So I've got y equals 2, and then 0 minus 3, quantity squared plus 1. In the parentheses, then, I have -3. We do the parentheses and do the exponent, so that gives me 2 times a positive 9 plus 1. That's 18 plus 1. That means y equals 19. So the point for this one is 0, comma, 19. Over here, our value was 9, so our point is 0, comma, 9. It's 0 because we let x be 0, and then the second number is the number that we calculated in our equation. Okay, now let's look at finding zeros algebraically. Those require us to let y equal 0. So let's see about what those look like. Those are going to be a little bit different and a little more work. So if I let y be 0, then I get the equation 0 equals x squared minus 5x minus 14. And if you want to, you could go ahead and switch the order of the sides so that it looks familiar. Now we are going to solve by factoring. We've done this lots of times. I need two numbers that multiply to give me negative 14, add to give me negative 5. That's going to be minus 7 plus 2. Now, when we solve by factoring, we set each factor equal to 0 and solve. So x minus 7 equals 0, or x plus 2 equals 0. I add 7 to both sides here, and I get x equals 7. Here I subtract 2 on both sides, and I get x equals negative 2. Connect the word or in between. So that means my two intercepts would be 7 comma 0 and negative 2 comma 0. If I'm asked to write the zeros, you can write them like this: 7 and negative 2. If you're asked for the actual intercepts, you should write them as points. If you're asked for zeros, you can just write the value where the graph crosses the x-axis. Okay, let's look at the next one. We are going to let y equal 0. So I have the equation 0 equals 5x minus 5. Again, I think it might be good to just reverse those sides so that it looks familiar. This one is not backwards FOIL. We have to pull out the GCF. So when we do that, we have 5 equals 0, or x minus 1 equals 0. Well, 5 can't be 0. Cross that out. So my answer is going to come from this. I add 1, and I get x equals 1. That means the y, or the x-intercept, is 1 comma 0. And if you're asked for the 0, you can just say that it's 1. If you're asked for the point, you would say 1 comma 0. All right, the last one is the trickiest. Again, I'm going to let this be 0. However, this guy has some calculations that I need to do in order to solve it. So the first thing I'm going to do is I'm going to square the binomial. So what that means, remember, that means write it down twice and use FOIL. Or you could use that shortcut that we've done in the past. But this, when you do FOIL on it, it turns into x squared minus 2x plus 1. So what I'm really solving then is 2 times the x squared minus 2x plus 1 minus the 32, and then it equals 0. So I also flip-flop the sides here. Okay, next I have to do distributive. And so that's going to give me 2x squared minus 4x plus 2, and then minus 32 equals 0. Oh boy. All right, so I get 2x squared minus 4x minus 30 equals 0. So now this is one of those where to factor it, they're not the nice ones to factor if there's a number in front of the x squared. However, notice here that these all are even. That means I can divide through by 2, all the way through both sides. So I end up with x squared minus 2x minus 15 equals 0. This one I can factor easily into x minus 5, x plus 3. Now I'm kind of running out of room. Let me see. Let me slide that up a little bit. So I get x minus 5 equals 0, or x plus 3 equals 0. Add 5, and I get x equals 5. Subtract 3, and I get x equals negative 3. Connect them with the word or. So that means the intercepts are 5, 0, and negative 3, 0. If you're asked for zeros, you can just write 5 and negative 3. For the next section on your worksheet, you are supposed to graph the function, state the y-intercept, zeros, and the vertex. It says you can find them algebraically or by using the graph. It's honestly, since you have to graph it anyway, that's what I would start with. If it doesn't work out with real nice numbers there, like fractions or whatever, then you can do it algebraically. But I would start by trying to just do the graph. So looking at this one, I can tell the vertex is 1, negative 4, because this is a right shift of 1, a down shift of 4. So the vertex is the point 1, comma, negative 4. So 1, negative 4 is right there. I also notice that there's no number in front, so my pattern of change is going to be the standard 1, 3, 5. So on my graph, I'm going to go over 1, up 1, over 1, up 3, over 1, up 5. I'm going to reflect those points across and get my quadratic formula all done. And here's my parabola. Do your best to make it nice and curved. Now come over and find the things that you're asked for. The y-intercept, we can tell is right there. That's the point 0, negative 3. The zeros are the x-intercepts. It looks to me like it's negative 1, 0 and 3, 0. We should maybe check that out. So if I'm going to check that out, that means if I put negative 1 in for x, let's see what happens. I get negative 2 quantity squared minus 4. That is 4 minus 4. That is 0. So our first 0 is negative 1. Now let's take the other one, which appears to be 3. So let's see if that works. So I take the same equation, and I'm going to put 3 in for x and see if it works. So I get 3 minus 1, which is 2, squared minus 4, which is 4 minus 4, which is 0. That means our other 0 is 3. So negative 1 and 3 are our zeros. And up here, we already knew what our vertex was. So that's 1, comma, negative 4. So after you graph it, you do need to check these 2 points and this one, if it's not obvious, to make sure that you actually get points that are accurately graphed and actually do work. So we were looking for the vertex, the y-intercept, and those 2 x-intercepts, which we also call zeros.